Welcome to the Quarkside Quantum Physics Podcast, an exploration of the fundamental structure of reality, where quantum laws govern matter, energy, and information. Here, uncertainty is a feature, not a flaw, and understanding begins at the smallest scales.
Okay, I have a request. It's a small one, but I need you to just commit to it for a moment. I want you to stop whatever you're doing just for a second.
Tune everything else out.
Exactly. Don't look at your phone. If you're driving, well, okay, please keep your eyes on the road, but just shift your mental focus. Try to really look at the now.
The present moment.
Right. You can watch the second hand on a clock or just, feel your own heartbeat. Thump, 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 thump. That sensation right there, that feeling of flow.
It's the most fundamental thing we experience.
We are obsessed with it. We live our entire lives in this tiny razor-thin slice of reality. We mourn the past because it's gone, it's buried in memory, and we stress about the future because it hasn't happened yet.
Right. It is the universal human condition. We treat the past as a fixed record. It's done, it's written, and the future. Well, the future is a void. It's a blank canvas waiting for paint.
That is the common sense view. I mean, 100%.
Yeah.
It's how I live my life. Next Tuesday is a ghost. It doesn't actually exist. It's waiting for me to create it. But, and this is why we're here today, we have a stack of research sitting right here on the desk that says, my common sense is. What's lying to me?
Lying is a polite way to put it. I mean, if we take the sources we're analyzing today, and they range from Einstein's relativity to the absolute latest papers on quantum gravity, that void of next Tuesday might be just as solid, just as real, and just as already there as the chair you're sitting in right now.
Which is, frankly, a terrifying thought.
It's deeply unsettling.
It implies the script is already written. It implies that while I feel like I'm improvising my life, making choices, I might just be reciting lines that were stamped into the fabric of the universe 13 billion years ago.
It does. And the more you dig into the physics of it, the harder it gets to hold on to that simple idea that time flows at all. We might be dealing with a universe that is, at its most fundamental level, static.
Frozen.
Frozen. A block of ice where we are just, trapped in the middle thinking we're swimming.
Okay, so the mission for this whole exploration today is to see if we can break that block of ice, or at least understand it. We're going to start with an intuitive feeling. The arrow of time, crash it head-on into general relativity.
Get completely confused by quantum mechanics.
And see if something like free will can even survive the laws of physics as we understand them.
It is going to be a messy investigation. We are going to have to dismantle your intuition piece by piece.
Good. I like messy. So let's start with the most obvious thing, the arrow. To me, this is the most tangible, undeniable proof that time exists and that it moves in one direction.
Okay.
I drop a coffee mug, it falls, it hits the floor, and it shatters into 1,000 pieces. I have never, not once in my entire life, seen a pile of ceramic shards on the floor suddenly jump up and assemble themselves back into a perfect mug.
Right. You were describing the macroscopic world, the world of big things, mugs, cars, people, omelets. And in that world, the arrow is absolutely undeniable. Events flow from order to disorder. We see effects follow their causes.
But the sources we're looking at highlight this massive contradiction right out of the gate. They claim the fundamental laws of physics. They don't care about that arrow at all.
And that is the reversibility paradox. This is really the first major hurdle we have to clear in this whole discussion. If you zoom in, and I mean way, way into the atoms that are making up that coffee mug, let's say you could film two of those atoms colliding.
Okay, just two particles bouncing off each other.
They bounce off each other. Now play that film backward.
It would look exactly the same. They'd just be coming from different directions and bounce off each other again.
Precisely. The laws of physics don't care. Newtonian physics, Maxwell's equations for electromagnetism, even the Schrödinger equation in quantum mechanics, essentially all the foundational equations we use to describe reality, they are time symmetric. They work just as well with a positive t moving forward or a negative t moving backward.
Wait. Are you actually saying that if I could somehow reverse the velocity of every single particle in the universe right now, the mug would unshatter?
In theory, yes. The math allows for it. There is absolutely nothing in the fundamental laws of motion that forbids those shards from gathering all their thermal energy, leaping up and fusing back into a perfect mug. The energy transfer, the momentum, it all works perfectly in reverse.
That sounds completely insane. I mean, it feels wrong on a gut level. If the math says the mug can unshatter, why doesn't it? Ever? Is physics just lazy? Why do we never ever see this happen?
It's not laziness, it's statistics. It's just probability on an unimaginable scale. And this is where we have to talk about the physicist Ludwig Boltzmann and his concept of entropy.
The universe tends toward disorder.
Yeah.
The messy room analogy.
Exactly. But we need to go deeper than just saying things get messy. To really get it, we need to talk about the difference between microstates and macrostates.
Okay, lay that out for us. I've heard the messy room analogy 1,000 times, but give me the technical version. What's the real engine behind this?
Okay, so think of your coffee mug again. The macrostate is the description whole mug. It looks like a mug. You can drink from it. It's a mug.
Simple enough.
But to achieve that specific shape, that whole mug macrostate, the trillions and trillions of atoms inside it have to be arranged in a very, very specific way. They have to be bonded here, not there. The handle atoms have to be with the handle atoms.
So there are very few ways for all those atoms to be arranged and still be called a mug.
Correct. A relatively low number of possible microstates correspond to the macrostate whole mug. Now think of the pile of shards on the floor. That is the macrostate. Broken mug.
Chaos.
A mess. But think about the atoms now. You can rearrange those shards in a billion different patterns on the floor, and it still just looks like a pile of shards. You can move the atoms around within the shards, you can twist them, scatter them across the entire room. It's still just a broken mug.
I see where you're going with this. There are vastly more ways for something to be broken than for it to be whole.
Trillions upon trillions upon trillions more ways. It's not even close. So as the system evolves over time, as particles jiggle and move around purely by chance, it is just overwhelmingly, staggeringly likely to move toward the state that has more possibilities, more available microstates.
So the arrow of time isn't a force? It's not some cosmic river pushing us forward?
No, that's the big takeaway. It's just the law of large numbers playing out. We are drifting from the incredibly unlikely state, which we call order, to the ridiculously likely state, which we call disorder. We perceive this statistical drift as time flowing, but really, it's just things shuffling into more probable configurations.
That is slightly depressing. So our entire experience of past, present, and future is just us losing a statistical game against the universe.
Essentially, yes. But this realization leads to the biggest, most profound problem in all of cosmology. If time is just a one-way slide toward disorder, that implies we must have started at the very top of the slide.
The Big Bang.
The Big Bang. The sources call this the past hypothesis. For the arrow of time to even exist today, for mugs to break, and for us to remember yesterday, the universe at the moment of the Big Bang must have had an entropy so low, so incredibly ordered, that the odds of it happening by chance are, well, astronomical. Doesn't even begin to cover it.
I saw a number in the notes attributed to the physicist Roger Penrose. I honestly thought it was a typo.
It wasn't a typo. Penrose calculated the probability of our universe starting in such a low entropy state by random chance. The number is 1 in 10 to the power of 10 to the power of 123.
Can you even visualize a number like that? Is there an analogy for it?
No, there are not enough particles in the entire known universe to write the zeros of that number on them. It is the working definition of a statistical miracle. It suggests that the beginning was special. It was highly tuned, incredibly specific.
So the only reason I can remember yesterday, and the only reason eggs break and never unbreak, is because the Big Bang was, for some unknown reason, weirdly tidy.
That is what some call the cosmological brute fact. We are surfing the wave of that initial unexplained order. But here's the crucial catch. Entropy explains the direction of time, why we go from past to future, but it doesn't explain the existence of time.
Right. Okay. Just because my room is getting messier doesn't prove that next Tuesday is already built and waiting for me. It just means that if I get to next Tuesday, my room will probably be messier than it is today.
Exactly. Entropy is a signpost pointing the way, but it isn't the road itself. To understand the road, to really grapple with whether the future actually exists right now, we have to leave thermodynamics behind and bring in the heavy hitter. We have to bring in Albert Einstein.
The presentism killer.
A very fitting nickname. Before Einstein, pretty much everyone, including Isaac Newton, thought time was this absolute universal clock. Tick-tock, tick-tock, everywhere in the universe at the same time. A universal now.
God's wristwatch. So if it's 12:20 p.m. here on Earth, it's 12:00 p.m. on Mars, and it's 12:00 p.m. in the Andromeda Galaxy, all at the exact same instant.
Right. That feels deeply intuitive. It feels correct. But special relativity took that universal wristwatch and just smashed it on the floor. Einstein showed that now is relative. It actually depends on how fast you're moving.
I always struggle to visualize this part. I get the time dilation thing. If I travel near the speed of light in a spaceship, I age slower than someone on Earth. But this is different. This is about simultaneity, about what's happening now.
It is. It's a much weirder concept. And the best analogy the sources we looked at rely on heavily is to think of the universe as a loaf of bread.
Okay, I'm listening. I like bread. How does a bakery item explain the nature of reality?
Imagine the entire universe, all of space and all of time, is one giant loaf of sourdough. You have length, width, height, and the long way from crust to crust is time. One end of the loaf is the Big Bang, the other end is the eventual heat death of the universe.
Okay, so everything that ever was or ever will be is already baked into this loaf. My birth, this conversation, the sun exploding, it's all in there.
It's all in there. Now, if you and I are standing still relative to each other, our concept of now is like taking a knife and making a perfectly straight slice down through the loaf. Everything contained in that one thin slice is happening at the same time for us.
A clean cut. It's a single snapshot of the entire universe at one instant.
But here's where Einstein's math comes in. He showed that if you start moving, even just walking across the room, your knife angles, you start to cut the loaf at a slant.
A slant? What do you mean?
Yes, your slice of now tilts. In the direction you're moving, your slice tilts into what, for me, is the future part of the loaf. And behind you, it tilts into my past.
But if I'm just walking, the tilt must be, infinitesimally small. I walk at maybe 3 miles an hour. That can't make a real difference.
It's microscopically, immeasurably tiny on human scales. Here on Earth, you would never, ever notice. But, and this is the absolute mind-blower, basic geometry tells us that a tiny, tiny angle, when extended over a massive distance, creates a huge, huge gap.
Right, the lever effect. If I'm holding a laser pointer and I tilt my wrist just a millimeter, the dot on the wall across the room might move 10 feet.
Exactly that. Now, replace the wall with a galaxy. This brings us to a thought experiment called the Andromeda paradox. The Andromeda galaxy is about 2.5 million light years away from us.
So it's very far down the loaf of bread.
Very far down the loaf. Now, imagine there's an alien invasion fleet in Andromeda. Right now, in my slice of now, me standing still on Earth, those aliens are in a council meeting debating whether or not to launch their attack on Earth. They haven't decided yet.
Okay, so for you, the fleet is grounded. The war hasn't started. The future is open.
Now you stand up and start walking just a slow stroll in the direction of the Andromeda galaxy. Because of that vast 2.5 million light-year distance, your slice of reality tilts dramatically by the time it reaches that galaxy.
How much of a difference does just walking make over that kind of distance?
It can make a difference of days, maybe even weeks. So in your now, purely because of your slow walking motion, your slice cuts through the Andromeda part of the loaf days after their council meeting. For you, the fleet has already launched. The decision has been made. It is a historical fact.
Wait, stop. This is the part that always breaks my brain. We are standing right next to each other. I take one step forward, and for me, an alien invasion has already begun. But for you, who's standing still, there's still peace.
Correct. And to make it even weirder, if you were to turn around and walk away from Andromeda, your slice would tilt the other way into their past. For you, the council meeting hasn't even been proposed yet. The idea of invading Earth doesn't exist.
So in this one spot right here, we have 3 completely contradictory realities all existing at the same time. The fleet is launching, the fleet is grounded, and the fleet isn't even a thought yet. How can that be right?
And that's the trap. That's the part that kills presentism. If the invasion is a real historical event for you, and we inhabit the same physical universe, it implies that event is sitting there in space-time. It has a coordinate. You're just viewing it from a different angle. You can no longer say, only the present exists, because your present is my future and someone else's past.
It's like a statue. I'm looking at the front, you're looking at the side, but the whole statue is solid. It's already fully carved.
That is the block universe in a nutshell. If you accept the core tenets of special relativity, you are almost forced, logically, to accept that the future is just as real and fixed as the past. It's all just geometry.
That makes me feel incredibly claustrophobic. It implies the future is just a city down the road. We haven't driven there yet, but the buildings are already built. The stoplights are already timed. Everything is in place.
Precisely. This philosophical view is called eternalism. The past, the present, and the future are all equally real, all coexisting in this 4-dimensional block. Our feeling of now is just an illusion of consciousness, like a spotlight moving across a stage that's already been built and set.
But hold on. If that's true, then my choice to interrupt you just now wasn't really a choice. It was. It was just a pre-written line in the block.
Under a strict interpretation of general relativity, yes. It was a fixed point in 4D spacetime that was always going to happen.
I refuse to accept that. There has to be an escape hatch. We aren't just creatures of relativity. We have quantum mechanics. And quantum mechanics is famous for being fundamentally weird and random. Doesn't that randomness save us from the block?
And this is the quantum wrench in the gears of the whole machine. Just when relativity convinces us that the future is fixed and deterministic, quantum mechanics enters the chat and makes everything fuzzy and uncertain again.
Because in the quantum world, things aren't fixed until you look at them, right? That's the basic idea.
Broadly speaking, yes. On one side, we have the Schrödinger equation, which describes how a quantum system like an electron in a cloud of possibility evolves over time. And interestingly, the equation itself, the evolution of that wave of possibility, is perfectly deterministic. It's predictable.
Until
measurement, the famous collapse of the wave function.
Cool.
When you interact with the system, when you measure the electron to see where it is, the entire wave function collapses from a cloud of possibilities into a single definite state. And this collapse appears to be completely random and irreversible.
Okay, so if the fundamental building blocks of reality are essentially flipping coins every time they interact, how can the future possibly be fixed? Let's say I have a choice to eat a burger or a salad for lunch. That choice ultimately depends on some neuron firing in my brain, and that neuron firing depends on some quantum event. Isn't the future genuinely open then?
That is the great hope for those who want to save free will in an open future. But, and I hate to be the bearer of bad news again, it depends entirely on which side of the quantum wars you're on. The interpretation of what quantum mechanics is actually telling us about reality matters immensely here.
Okay, let's break down the camps. Who are the main combatants in these wars?
Well, first, you have the oldest and, the standard textbook view. It's called the Copenhagen interpretation from Bohr and his colleagues.
Right.
It basically says the wave function isn't real reality. It's just a mathematical tool we use for making predictions. Reality is created in the act of measurement. So in this view, the future is genuinely open because nothing is decided until the moment of collapse. The electron wasn't anywhere until we looked.
Okay, so that's a point for team free will. The block universe is cracked. The future is unwritten.
Perhaps. But then you have the second camp, the hidden variables interpretation, which was famously championed by physicists like David Bohm. They looked at that random electron and essentially said Einstein's famous line, "God does not play dice."
Meaning that the randomness is just an illusion. It's fake.
Exactly. This view says that the particle always had a definite position and a definite path. We just didn't know the hidden variables that were guiding it. It's like a complex magic trick. It looks like magic to the audience because they can't see the hidden wires and mirrors, but the magician knows exactly where the card is going to end up.
So if the hidden variables interpretation is correct, then all that quantum weirdness is just a sign of our ignorance, and we're back to a fully deterministic universe.
We are right back in the block universe. The future is fixed and determined. We just can't predict it because we don't have access to all the data.
That's deeply disappointing. What about the third one? The one that science fiction absolutely loves.
The many worlds interpretation. This one is utterly fascinating when you think about it in terms of time. It was proposed by Hugh Everett, and it takes the Schrödinger equation at its word. It says the wave function never collapses.
It keeps going. What happens at the measurement then?
It branches. The entire universe splits. Every single possible outcome of a quantum measurement actually happens. So in your lunch decision, the universe splits in two. You eat the burger in one branch, and an identical copy of you eats the salad in another branch.
So the universe is constantly, infinitely splitting into this massive fractal of different realities.
An ever-growing branching tree of timeline.
Wait a minute. If the universe splits, then the future isn't a single line anymore.
Correct.
So does the future exist in the many worlds view? Or is it being created?
All of them exist. Objectively, from a God's eye view of this multiverse, the entire branching structure is a fixed deterministic object. Subjectively, to you, the future feels open because you don't know which branch of the tree your consciousness is going to travel down.
But the whole tree is already there. All the branches are already mapped out.
The structure is rigid. It's a giant branching crystal.
That is somehow even worse than the block universe. In that one, at least my choices are singular. This makes my choices feel meaningless because I end up making every choice anyway.
In a sense, yes. In the block universe, you play one pre-written role. In many worlds, you play every possible role in every possible play. But in neither interpretation do you actually get to write the script yourself.
So quantum mechanics, which I thought was our great hope for freedom, might just be a cage made of infinite mirrors.
It's certainly looking that way. Relativity says it's a block. Many worlds says it's a branching block. Hidden variables says it's a secret deterministic block. The open future of the Copenhagen interpretation is starting to look like the outlier.
Is there any theory that just gets rid of the problem entirely, like just kills time itself?
Ironically, yes. And this is where things get even stranger. If we try to go to the absolute deepest, most fundamental level of reality that we can currently probe, which is trying to combine gravity or general relativity with quantum mechanics, we get an equation. It's called the Wheeler-DeWitt equation.
And this is supposed to be the master equation for the whole universe, a theory of everything.
It's an attempt at it, yes. It tries to describe the quantum state of the entire universe as a single object. But there is something profoundly strange about this equation. Something is missing.
What's missing?
The variable for time.
What do you mean it's missing?
I mean the letter T. It just drops out of the math entirely. The equation has variables for the geometry of space, for the matter fields within it, but there's no variable that corresponds to a clock. The equation describes the universe as frozen, static, a single, timeless now.
Hold on. So at the most fundamental level of reality we can describe mathematically, time doesn't exist at all.
That is one very powerful, very influential interpretation. It suggests that the universe as a whole quantum system just is. There is no when. It's a vast collection of static configurations, all existing timelessly.
Then why are we having this conversation? Why do things change? I'm definitely getting older. My coffee's getting colder. I can feel the passage of time in my bones. If the math says the universe is frozen, then the math has to be wrong.
Or our perception is wrong. This is what's known as the problem of change. If the fundamental equation of reality is timeless, how do we get the vivid experience of a Tuesday turning into a Wednesday? The leading theory to solve this is called emergence.
Emergence. Okay, that's like how individual water molecules aren't wet, but if you put enough of them together, the property of wetness emerges.
That's a great analogy. Or, closer to the analogy in the sources, heat. An individual molecule isn't hot or cold, it just has a certain amount of kinetic energy. The concept of temperature is a statistical average of the motion of a huge number of molecules. It only makes sense, it only emerges at a macro scale.
So time is like heat. It's not a real fundamental thing.
Exactly. The idea is that at the most fundamental quantum level, there is no time. But as you zoom out and look at the relationships between all these different static quantum states of the universe, a variable emerges that looks and acts just like time does for us. It implies that time isn't a fundamental ingredient of the universe, it's a byproduct. A secondary effect.
That absolutely blows my mind. We spend our entire lives ruled by the clock, obsessed with saving time or spending time. But the clock itself might just be a statistical illusion generated by a timeless reality.
There is even a mention in the research of some modern ideas from string theory and holography, specifically something called the AD-SCFT correspondence.
I saw that. It sounded incredibly technical, and I skipped right over it.
It is, but the core idea is beautiful in this context. It models a universe where gravity exists in a higher dimensional bulk space. Think of it like the inside of a soda can. And then quantum fields exist on the lower dimensional boundary, like the label printed on the surface of the can.
Okay, I think I can picture that.
In some versions of this theory, time exists on the boundary, on the label, but it emerges from a timeless bulk, from the inside of the can. It just reinforces this idea that time might be an emergent property that depends on your perspective, or even which dimension you're looking from.
Okay, my brain is officially starting to melt a little bit.
Yeah.
We have a universe that's a fixed block.
Yeah.
Or it's a timeless, frozen quantum state. But I am sitting here, my heart is beating, I am feeling the seconds flow by. Why? If physics says the block is real or the universe is fundamentally timeless, why is my experience so convincingly, so powerfully different?
And that brings us to the final and maybe the hardest piece of the puzzle. This is the intersection of physics and neuroscience. The hard problem of consciousness meets the hard problem of time. If the universe is a static movie reel, why do we feel like we are watching the movie? Why aren't we just a series of static frames?
Exactly. Why do I feel like I'm moving through the block universe?
There is a concept from neuroscience called the specious present, and it suggests that what we call now isn't an infinitely thin, instantaneous point in time. It's actually a window.
A window.
Yes. Your brain is constantly integrating sensory inputs over a short duration, fractions of a second, to maybe a few seconds. It takes the sight of my lips moving and the sound of my voice, which actually arrive at your brain at slightly different times, and it stitches them together into one coherent moment.
So now is actually a construct. It's a smeared out delay.
We are always living in a delayed broadcast, a processed, reconstructed version of reality. We live in a thick present, not a thin one. And this helps explain that feeling of flow. We aren't experiencing one static slice. We're experiencing a blurred integration of many slices at once.
But that still assumes that we are moving from one set of slices to the next. It brings up that spotlight idea you mentioned earlier.
The spotlight theory. This is the intuitive idea that our consciousness is like a spotlight that scans along the timeline of the block universe, illuminating slice after slice and making it present.
That makes perfect sense to me. The whole movie is on the reel, but the bright light of the projector is what moves and creates the show.
It does feel right. But here is the deep logical problem with the spotlight theory. What moves the spotlight?
Consciousness moves it. I move it.
But if the spotlight moves, it has to move in time. You need a second layer of time, a hyper time for the spotlight to move through the regular time of the universe. And then, what moves the spotlight in that second time, you need a third time to explain the second.
It just becomes an infinite loop. It's circular logic.
Exactly. It's a philosophical trap that doesn't actually explain anything.
So if the spotlight doesn't move and the block doesn't change and the whole thing is static, why do I feel like I have agency? Why do I feel like my choices matter? Why does it feel so powerfully like I can choose what to do next?
This is where we have to get really careful and almost redefine what we mean by choice. In a block universe, your choice to raise your hand is a real event. It absolutely exists there in the block. And that event causes the event in the next slice where your hand is actually up.
Okay, so there's still cause and effect.
Yes, but the choice itself is a fixed, embedded part of the space-time geometry. It's what the sources call a dependence relationship, not a creative act. The future slice depends on the present slice, but the present slice is already sitting there, fully formed.
That is a subtle but absolutely huge difference. My choice matters in that it's part of the causal chain, but my choice was also written.
Written, or perhaps a better word, is embedded. It's part of the pattern.
But there was an interesting angle on this from information theory in the notes. It says the flow of time is actually the flow of information. What does that mean?
Yes, this is another way of looking at it. Think about it. Why do we remember the past and not the future?
Because the past already happened.
Or, to put it in terms of entropy and information, the past is low entropy information that has been organized and recorded in our brains. The future is high entropy. It's disordered, unprocessed information from our perspective. The feeling of an open future is actually just a feeling of a profound lack of information.
So when I say the future is open, what I'm really saying is I don't know what happens next.
Precisely. If you could know the position and velocity of every particle in the universe, and you had a computer powerful enough to calculate all their interactions, the future would look just as rigid and recorded as the past does. Our powerful sense of free will is, in a very real way, a direct measure of our own ignorance.
Ignorance is freedom.
In a deterministic universe, it is the only freedom we have.
So, okay, where does that leave us? We've crashed all these theories into each other. Let's try to synthesize this whole investigation. What's the final verdict? Do we live in a block, a branching tree, or just a statistical mess?
The verdict is that it's profoundly and fundamentally messy. The evidence is contradictory. You have relativity, which points very, very strongly to the block universe. The future exists.
But then you have thermodynamics, which gives us the arrow of time, but it has to rely on this unexplained miracle at the Big Bang to get started.
Exactly. Then quantum mechanics comes in and offers this glimmer of true randomness. But then most of the popular interpretations, like many worlds or hidden variables, snatch it right back toward a kind of superdeterminism.
And finally, quantum gravity, the deepest theory of all, hints that the whole stage, the whole concept of time, might just be an illusion of our perspective.
It feels like the more we learn, the less time looks like that simple ticking clock on the wall. It feels like we're fish trying to describe water. It's so fundamental to our existence that we can't step outside of it to see what it really is.
But there's a human takeaway here, right? A kind of silver lining in the source material. It seems to be that even if the future is absolutely fixed in some hyperdimensional space-time, our experience of it is not.
That's the key. Because we can't read the script.
We can't.
We are embedded inside the movie. We can't skip to the end. So for us, living our lives from our limited perspective, the future is effectively open because we possess absolutely no information about it. We have no choice but to live as if it is open.
So the open future might be a trick of perspective, a necessary illusion, but it's the trick that allows us to be human. If I don't make the choice to get out of bed in the morning, nothing happens in my timeline. The fact that me not getting out of bed was already written into the block doesn't change the fact that I am the one who has to go through the motions.
Exactly. Your agency, your consciousness, is the mechanism by which the future becomes the past, even if the whole structure is static when viewed from the outside. You are the needle on the record player. The music is already pressed into the vinyl, but the song only happens because the needle moves along the groove.
I like that. We are the music.
We are the music.
I want to leave our listeners with one final, slightly provocative thought that came from the deeper end of the cosmology section we looked at. We talked a lot about the Big Bang being a brute fact, this incredibly low entropy, highly ordered start to everything.
Yes, the initial push that got the whole arrow of time flying.
And we talked about how that past event pushes us forward. But there was a fascinating suggestion in some of the research that the end of time, the far, far future, might also have special boundary conditions.
That is a wild and fascinating idea. Some cosmological models suggest the universe isn't just being pushed from the past, but it's also being pulled toward a very specific future state.
It's like teleology, a purpose.
In a strange, physical way, yes. If the universe has to end in a certain configuration to satisfy the overall equations, maybe it has to settle into a specific vacuum state or end in a big crunch that mirrors the Big Bang, then the future is constraining the present just as much as the past is.
Imagine that for a second. We always think of the past pushing us forward. But maybe the future is pulling us in. Maybe the script for the universe is written from both ends, and we are just living out the part where they meet in the middle.
It completely turns causality on its head. It would suggest that the choice you make today might, in some incomprehensible way, be determined by where the universe needs to be in 1 trillion years.
And on that completely mind-bending note, I think we are officially out of time, whether it exists or not.
I suppose we are.
This has been a heavy investigation. We broke the mug, we sliced the loaf of bread, and we split the universe into infinite copies. Thanks for listening to us try to put it all back together.
And keep questioning the clock.
We'll see you in the future. Or, I guess, we'll see you the next slice.